So pretty good turnout for a review. Any questions in particular you want to review? Ellie, do you have any announcements on, like when you're getting together with people or whatever?
So there's a session tonight, and there'll be a session Sunday afternoon, as well as the concrete show, our kids are for those. We have our Sunday session will be noon to 1:30.
Is that tomorrow? Tomorrow?
On Sunday.
On Sunday.
On Sunday? Any other times?
That happens tonight.
I can't hear you. My ears are stopped up.
Tonight from 5 to 6:30.
Tonight from 5 to 6. And where is that?
A&S,
A&S what?
136.
And when else?
Sunday from 12 to 1:30.
That's new. Same place?
Same place.
So take advantage of that if you need help. And of course, I will go over things, but if you guys have specifics you want to go over, we have today and Friday.
Can you look at the percentile stuff?
I fixed one of these. So under practice for test one reactions, I put reactions, limiting reactant. I should have put limiting reactant and percent yield. I only put a couple in here, but this third one didn't have answers. It had gobbledygook in there, and I fixed it this morning. So let's just do this one. I'll go ahead and go to the board. Let's see if I did it right. All right, the third question, limiting reactants. And these are kind of a long walk. There's the balanced reaction. So first, that's our first task, find the limiting reactant. All right, and as I've said before, you just pick one, either this reactant or this reactant. I'll just pick Cl2. Grams of Cl2 is mentioned, grams of F2 is mentioned, and grams of ClF3 is mentioned. That means we're going to need all of this. Cl2 times F2 These are the numbers I'm getting from the periodic table. This is 1 CL, you've got 3 Fs. Five, 4, 5. 57.00, you add them up. So we're gonna need all 3 of those. Okay, to start with, I decided I would start with CL2, so I've got 4.39 grams of CL2. Next, we need grams of CL2 on the bottom. We're going to use this 70.90 grams per 1 mole. Grams of CL2 is 1 mole of CL2. So I'm using this, which is the more formal statement of that. The grams go on the bottom, so 70.90 mole 2. That tells us moles of CL2 goes on the bottom. That's this mole ratio. 1 mole of CL2 to 3 moles of F3. That tells you moles of F3 on the bottom. Now we're using this.
Isn't it supposed to be times 3, not times 2 for the reporting?
Yes. Moles of F2. What did I do here? I did 2.
I know, but it says in the original equation it's F3, so, oh, it's F2? Okay.
Sorry. That is what's on there, right? I just wrote it wrong. 3 F2, yeah. I just wrote it wrong. CL2, 3 F2, 6 Fs, 2 CLs, that's right. But I did calculate it right over here. So this means 38.00 grams of F2, more formally written, is 1 mole of F2. Now I'm using this, moles of F2. 1 mole of F2. And I point up here where the information is given. It's saying this is what we have of F2 as stated by the problem. This is how much we need. Calculate. And that's it. Grams per mole for the one thing, the molar relationship between the one thing and the other thing, and then the grams per mole of the other thing. That'll give us grams of F2 that we need. 4.39 times 3 times 38 divided by 70.90. This is how much we need, and this is how much we have. We have 2.94, but we need 7.06. So what does that tell us? F2 is the limiting reactant, and that's what we needed to know. Find the limiting reactant. If we had chosen F2, we would have gone through all this and we still would have found out that this is limiting and this is excess. So it didn't matter which one we started with, we would have figured it out. So now that we know which one is limiting, now we're going to use the limiting reactant to predict products. Meaning we're gonna compare these two now. We're gonna use that mole ratio. And we'll start with F2 this time. You guys good with that? All right, so starting with F2, we have 2.94 grams. Grams per mole for F2, 38 grams. So we need grams of F2 on the bottom. So 38. We need moles of F2 on the bottom. Now we're using this mole ratio. 3 moles of F2 to 2 moles of ClF3. Now we're going to use the grams per mole of F3, that's down here. 92.45 grams of ClF3 is 1 mole. On the test, I might just give you these to save you a little trouble. I might just say Cl2 is 70.90 grams per mole, and F2 is 38.00 grams per mole, etc. It just saves you a little trouble. Okay, 1 mole of ClF3.
Will you give us polyatomic ions too, or do we have to
Yeah.
know those? Okay.
I really mean for you to not have to memorize any of those charts of information. 92.45 grams of ClF3. And what is this called that I'm calculating here?
Theoretically.
Good, see, theoretical yield. It tells you that this many grams of ClF3 is produced. What do we call that?
Actually.
Actual yield. And I've said before, if you can remember, finding the limiting reactant, that's a long walk. Finding the theoretical yield, that's a long walk. Actual yield is always very obvious and easy. So think of it that way. The reason it's obvious and easy, because it's given to you. So don't get confused about that. That's the actual yield, what you're told. But theoretically, how much we should get? 2.94 times 2 times 92.45 divided by 38 divided by 3, and I've got, if I do my significant figures right, 4.77. This is what I actually got. This is kind of what I should have gotten theoretically. They're very close, so it's going to be high 90s%. To figure out limiting, I'll put number 3 here. No, to figure out percent yield. Percent yield is actual over theoretical times 100%. So here I'm putting actual 4.67 over theoretical 4.77 times 100%. 4.67 divided by 4.77 times 100 to 3 significant figures, 97.9. That's the percent yield. Make sure I did that right. 97.9. Any other things you want to know? No, if I did actually put the units in, that's a good question. I kind of skipped that, but grams, CLF3, grams, CLF3. That cancels and that cancels. That's why no units show up. The grams of CLF3 cancel in both cases. We usually say it's unitless. In some sense, the unit is the percent. This is where the unit shows up. You just write it here. Any other questions on this? Anything else you want to cover? I was just going to start with molarity or something. No other specific questions?
Can we do molarity practice?
Yeah.
Thank you.
Let's do, let's zero in on, okay, molarity shows up. In chapter 8. I'll go down to the exercises. There's some here. Let's see what the pictures are. Well, let's do. Most basic way to get a question here would be like in the exercises in chapter 8, number 22. Molarity. This is like number 21. All right, this is the most basic way you can get this question. It's moles per liter for molarity. And notice grams aren't brought up anywhere. So the identity of the solute, this is a solute. Water is probably dissolvent. You dissolve that in water. You dissolve 0.55 moles of that in 9.56 liters of water. The fact that grams aren't mentioned tells you you don't need the grams per mole of this. You just do moles per liter. In 9.56 liters of Na2SO4 solution. You just divide it. 0.55 divided by 9.56. two significant figures or three significant figures. My calculator says 0.5753, but we're just going to keep and you just put him. That would be the answer. Those are really fundamental. Let's do. Okay, 28. I think that's like number 27. It's not, but let's do 27 and then 28. This time, um, 27. It's got an A, B, and C. A is 0.556 liters. So there's two problems with this. So this time, remember that 2.3 molar solution, I'll write the KCl solution, is the same as 2.3 moles of KCl in 1 liter KCl solution. So that's what this means, and it helps to have that because then you can see moles and liters, and you can kind of see what to do. But I would start with this. KCl solution. It's the same. How many moles? 2.3 moles of KCl in 1 liter. And that'll solve it. .556 times 2.3. My calculator says three significant figures, two significant figures, so it's those two I'm keeping. 1.3, that cancels moles KCl. There's your answer. You notice grams are not mentioned. That's why we're not looking for the grams per mole here for KCl. It's only when grams comes up that you need it. All right, let's just go to 28. This one would be done exactly the same way. Let's go to 28. Because this one brings up grams. Determine the mass of glucose in each glucose solution. C6H12O6. Five liters. 122.0 milliliters. Mass is mentioned, so we're going to have to do this. .01 is off the periodic table, 1.01 is off the periodic table, and this will be 16. And this is, again, something I might just give you on the test. Just to save you a step. 6 times 12.01. This is going to be 12. 6 times 16 is 96. 6, 7, 8, 1. Where did that come from? 6, 7, 8, 9, 10. There's our grade from 180.18. 10. Okay, so we're going to need that. We're also going to need this to be in liters. Let me write this out. This is 0.500 moles of C6H12O6 in 1 liter of C6H12O6 solution. So that's this written out, and that's your clue that you need to be in liters for this. This in liters is 0.1220 liters. So I'll use that. And that's liters of liters C6H12O6 solution. So once you break all of this out, 180.18 grams of C6H12O6 and 1 mole of C6H12O6. Now you've broken out all the pieces and you can solve. I will start with this. I'm putting the solution on this because it says liters. I need liters of glucose solution on the bottom. This is the only other place you'll see liters of C6H12O6 solution. So 1 liter of that. So we've used this. Now we're down to this. We need moles on the bottom. One mole is 180. And that'll give you grams, aka the mass of. On a test, I would probably say just to specify the units. Grams of C6H. And your answer here, 0.1220 times 0.5 times 180.18 equals, my calculator says, that's 4 significant figures, that's 3, that's 5, so we need 3, so it's that. The 9 will round to 0, so it's 11.0. That's where we'll land. So slightly more involved on that one. It's 28. All right, let's do. It's nice of them to say ethanol without getting the formula. Oh, you don't need it. I guess we'll do this one. Probably did this one already when I was going over this. Okay, sucrose. Got to do that next. So this is 30. This time it asks for volume. What volume? It says 55.8 grams. So what volume? Sucrose is C12, H22, 11. I'll tell you the formula. I won't just do this because y'all don't know those. What volume? Uh, 0.200. Grams of sucrose is mentioned, so we're going to need this. And again, I might just give you the grams per mole. If it's something small, maybe I won't, but 12.0. 12 times 12.01. 2.22. 2.22. 16 times 11. 4, 3, 6, 7, 8, 9, 10, 11, 12. So 342.34 grams C6H22O11 is 1 mole of C6H22O11. We're going to need that. Break this out into 0.200 moles of C12. C12H11O. H22O11 is 1 in 1 liter of C12H22O11 solution. So we're going to need that. That's just this broken out more formally. And then we're going to use this 58 grams of C12H22. So this broken out formally, I would put 55.8 grams of C12H22. That tells us grams of this needs to be on the bottom. We've used this. The only place you're going to see grams is here. 342.34 is 1 mole of 11. We're going to need moles of C12H22 11 on the bottom. It's going to be this 0.200 moles. Is 1 liter C12H22O11 solution. And that's going to give us the liters of the solution. What volume? I would probably say just to specify what the units should be. 55.8 divided by 342.34 divided by 0.2. Calculator says 814.97926 more. That's exact. That's exact. That's exact. 3 significant figures, 5 significant figures, 3 significant figures. So we want 3. So this is going to be 0.85. And then liters of C12, H22, 11 solution. Answer. So that's a good run through molarity. Let's look at what happened in the quiz. I was kind of throwing these together at the end there. Moles and grams and how many. No, that's not molarity. Did I do one for molarity? I did not. That's still one I need to make for you guys. But use those as a guide, those few that I just did. Look at 21, 22, These are less convenient than having the written as quizzes in D2L.
Yeah.
So maybe I'll get to it. 27, 28. But I've got to go back north again today to work with my dad's son. So look at that for a guide on the layer for the exercises. Hopefully I'll be able to work from home. Anything else you guys want to go over specifically?
Can you do some practice where you would have to use Avogadro's number?
Yeah, that's the, so there is a quiz on that. And that's this one, how many atoms / molecules? So I do have a quiz on that. The key for these is when you see how many, and there's not a unit. There's not grams, there's not moles, there's not anything. How many carbon atoms are 2.87 moles of carbon? For a label for this. And I would subtitle that using Avogadro's number. This first one in the quizzes says how many carbon atoms in 2.87 moles? So it says how many carbon atoms. It doesn't say how many grams of carbon atoms. It doesn't say how many moles of carbon atoms. It doesn't say how many liters. It doesn't have a unit at all here. That's your clue that you're going to use this number, and it doesn't have a unit. It'll just have a label. Meaning what I'm using here is 1 mole of carbon atoms is 6.022 times 10 to the 23 no unit carbon atoms. That's going to be involved here. Now that we know the context is carbon atoms, I can write it like that. Instead of just writing this number, I write it like that. All right, and I would start with not only is grams not mentioned here, it's not mentioned anywhere. So we're not going to need the grams per mole of carbon here. So once you see moles of C atoms, we'll go no unit. And that'll solve it. When it's me, I would just go, I'm not used to having scientific calculators. I learned everything I knew long before scientific calculators. Actually, you could buy them, but they were like $250, so I didn't ever get those. I would just do that multiplication and leave 10 to the 23 out here. Moles of C, no unit here. This is all numerical value. No unit, C atoms. So I'll calculate that part first and only deal with the powers of 10 if I have to do scientific notation. 2.87 times 6.022. My calculator says These are our significant figures, 3 and 4, so I'm going to keep those 3. If I wanted scientific notation, if I did it this formal way, if I want that decimal here, that's 10 to the negative 1. But I'm also going to do 10 to the 1 so I don't change the value. And now I'm going to swap these two. And once I swap those two, I'm going to apply this here, so I got 1.73. And these two I'm going to put together, that's going to be 10 to the 24. So there it is in scientific notation, and here it is without scientific notation. What else did I like here?
On the test, do you want every single answer in scientific notation?
For each question, I'll say the last sentence in the question would be, put your answer in standard scientific notation. If I don't put that in there, then you don't have to put it in scientific notation. Okay, question 6 and 7 mentions a mass, aka grams. Question 6 is, what is the mass of 2.83 moles? It's another big molecule. So question 6 in that quiz. What is the mass of 2.83 moles of C12H36? Not all molecules are this huge. I don't know why these are the ones I have for examples. 12.01, 1.01, 16. This is 144 something. This is going to be 26.26. This is 32.00. 12.01 times 12. Okay, I'll add that up. Let me write the question. What is the mass of 2.83 moles? Let me say it this way. Two different ways to state this problem. I wanted to write this just to point out how many grams, aka what is the mass. So it mentions grams, and then it says moles here, moles here. None of these have that space. See what I mean? There's no how many this without units there. So the fact that it mentions grams and moles, and there's no holes where there should be a unit, that tells you you're not going to use the 6.02 times 10 to the 23. Meaning this one will just be, grams is mentioned, so you're going to need this. Plus 32 This comes to 202.38 grams per mole. That is 202.38 grams of C12H26O2 is 1 mole. C12H26. The fact that grams is mentioned means you're going to need that, grams per mole. That's given in the problem. And now you're going to need the grams per mole. Moles on the bottom. So 1 mole. That'll give us grams. C12H26O2. And that's the answer. How many grams? What is the mass? I'm more likely to ask it like that on the test. So I'll specify the units. 2.83 times 202.38. Five significant figures, 3, that's exact. So I'm keeping those. The 7 rounds to 2. There's the answer. 573. How many moles of PCl3? This is question 7. How many moles of PCl3 are in 0.257 grams of PCl3? Moles mentioned here and grams mentioned here, and there's no spaces, so this number won't show up here. The last 2 questions, 6 and 7, don't involve Avogadro's. There's more examples like 6 and 7 here. Yes. What is the mass in grams of 2.63 moles of nickel? So nothing in moles underscore working involves Avogadro's number. All of these you can just work in grams per mole. You want to do more of those? Anything else you want to do? Isotopes, I still have to fix one of these questions. This one, number 4 in isotopes. Radon sheets have RA dash some number. So that one's going to screw you up. I'm gonna fix it. Radon's down here, it's 86 protons. Sorry. just let me fix this while I'm looking at it. I noticed it the other day. It's 86. Say radon. Radon should be 86, so that one would have screwed up.
I know, that's why I think about that. Did you see his like knee braces he had during practice?
That's when I was doing it. He goes to the patient.
I go, oh. Okay, I know.
Kate, tomorrow we have yours and I go out and
It's crazy.
I'm so excited.
Oh, I was looking wrong. 88.
That's good.
It's not good for me.
Anything else you guys want to go over?
Can we go over isotopes?
Yeah. No, we can't. Isotopes, let's do these. This is in here. Okay, isotopes. Isotopes. Two different ways you can see these. Do it like this. There's the quiz on isotopes. I will give you these two. Neither of those are the atomic mass. Atomic mass for K, there's K on the left side, 39.10 is the atomic mass. But if you look on here, it's 19,
Is the atomic number?
yes. Also, you could also say number of protons. 19 is synonymous with the atomic number and the number of protons. Remember what this is called?
Mass number.
And that's protons plus neutrons. So if you wanted to know how many protons and neutrons were in this, if you were just given this, number of protons is 19, neutrons is going to be 40 minus 19. Is that 21? No, it's 21, right? So neutrons is 21. The other way you might see these is a different symbol. Remember I said that this and this are kind of synonyms. If you look up K on the periodic table, you're going to see the 19. So this is really kind of redundant when you write it this way. The other way you could see these is, you might see that symbol, and then you would see, so this time it's just the mass number. And you look on the periodic table to find the protons. What you see is, I think that's way down there. That's an obscure one. Where's technium? Man, these obscure ones I can't find quickly. SCTC. No, it exists. You guys see it?
Yes, it's,
Where?
it's next to Emma, Go up. Yes.
I thought it was down here. All right. So how many protons does this have? Each-
43.
It's 43. So you get the 43 from the periodic table. This is the mass number, so this is protons plus neutrons. 56, 9, 8, 7, 6, 56. Did I do that right?
Yeah.
So that's how many neutrons. That's all there is to these questions. You're just trying to figure out the number of neutrons. The number of protons are just, they're given. Once you see the symbol, you can look on the periodic table and find the number of protons. So this is protons plus neutrons. This is protons plus neutrons. Two different ways you might see those symbols. Anything else you want to go over? We still have Friday.
On the test, are we gonna have to like determine which group the elements are in, like halogens, silver gases, will that be open?
I don't typically ask those questions.
Okay.
The only ones I gave you is earth metals, alkaline earth metals. No, alkali metals, alkaline earth metals is 2. These are the halogens. These are the chalcogen. These are the noble gases. But I just like to mention them because if you're going to do the reading, it helps you follow because they say those. But I just find that not an important thing. Anybody can memorize a few things. You guys notice I lean on the calculations pretty hard because that's the thing you want somebody to explain to you. Everything else is just memorizing.
Do you want to go over the naming, the ion,
Yeah.
the formulas, or
Yeah, let's do some of that.
Send it over for that.
Okay. Ions, ionic formulas. That is,
You have a quiz over it.
sorry?
You have a quiz over it.
Oh, I think I did. Do I not?
Yeah, you do.
Okay. Ionic compounds, formulas and naming. We can do that. ionic compound formed when magnesium and oxygen combine. There's magnesium, and there's oxygen. The first thing you need to figure out is what is the charge on things.
2 plus.
So magnesium is 2 plus. Magnesium, what is the charge?
2 plus.
Oxygen, what is the charge?
2 minus.
2 minus. So it's just MgO. You got plus 2 and you got minus 2. It balances as MgO. 1 Mg, 1 aluminum and sulfur. What's the charge on aluminum?
3 plus.
Plus, what's the charge on sulfur?
2 minus. So you just flip it.
Yeah, essentially you flip them. It's going to be Al2S3. If you have 3 of these, then you'll have -6. If you have 2 of these, you'll have +6. And that's what you're trying to do to balance them. So you get 2 of these and 3 of these. That's the formula.
So when you put the number in front, and when you put it as a.
It's only in reactions that I put the, you mean something like that?
Yeah.
It's only in reactions that I do that.
Okay.
How about this? What's the name of this?
Magnesium oxide.
Magnesium oxide. We got magnesium, you've got oxygen. The metal, you just leave the name normal. The non-metal is the one you do as an ion. How about this?
Aluminum sulfide.
What was the charge on aluminum?
3 plus.
So we're not calling this aluminum 3 sulfide. Why not?
Because it's an ionic bond.
No?
It's not a transition.
Yes, it's not a transition. It's only these in the fat part in the middle that we have to put the parentheses and then the Roman numeral that reflects the charge on the ion. Let's look at one of those. What's the name for copper fluoride? Well, it shows you Cu. It shows you, and you have to infer the charge on copper. Copper's a transition metal.
Do you have to write the 1?
No, in this case, we're not writing ones. It really is 1 copper and 1 Cl. But it's just, I don't know why chemists are quirky like that, but it's just one of them. We just put it like that. So how do you figure out what the charge is on copper?
You know, chlorine is 1 minus.
Yes. Chlorine is 1 minus. There's only 1 of them. There's only 1 copper, so it's got to be 1 plus. And again, we don't write the 1 there either. I don't know why. So now, if you're going to say the name, it's chloride. And in here, I'm going to put a 1, Roman numeral 1, just to emphasize that it's copper 1. There's such a thing as copper 2 chloride as well. If it were copper 2 chloride, it would be like that. And then you would go, there's 2 negative charges. There's a Cl and a Cl. And there's only 1 copper there. And you got to split those 2 charges, or no, the 2 charges add up to 2 minus. So you got to add up to 2 plus. So that has to be 2 plus. And then that would be copper 2 chloride. This one you can just look up. I don't know if I ever put that in here. Did I ever put that chart in here? I guess I didn't. Oh yeah, I did. So I'm going to give you those on the test too. So you should just be able to look them up.
So we don't have to know when things are iodine 8 and
Sorry?
So we don't have to know when it's a height versus 8 versus height versus all that.
They're all here. The only twist is, this is chlorate, but if I look at the periodic table, I mean, there's chlorite, there's chlorate, there's perchlorate, and there's hypochlorite. Those are all Cl, but let me get to that. The other ones you might get instead of Cl are all in this column. You might get fluorate, fluorite, hyperfluorite, or you might get bromate, bromide. Sorry?
How do we know what any of that is without a chart?
Here. Do this.
Is this a paper test or a computer?
It's a paper test.
Okay,
Yeah.
so I assume.
I never said that, but yeah, y'all will come to class and do it on paper. And I'm pretty sure I can do it all multiple choice, as long as you show me the formulas you use when you calculate things. So
Are we allowed to use graphing calculators if we want to do those?
you'll have to use those.
Okay.
Hypochlorite. So those are the names of these. Notice that they're all negative, one negative, and there's Cl there. And I've got chlorite, chlorite, chlorate, chlorate. You can also have this is for Cl. If it was Br, bromite, bromite. And that's just BRO, BRO2, see what I'm saying?
So why is it height and not higher? Is that just because of oxygen?
This is just the naming convention. I don't know why it's light and 8. Historically,
There's
that's
sometimes we'll put I and sometimes we'll put I.
depending on how many oxygens are there. This is called hypobromite. This is called bromite. This is called bromate, and this is called perbromate.
Yes. But like if there isn't an oxygen, then it's I instead of I.
Next, I don't know what you're asking. You see the pattern between this and this? What is your question?
Sorry, I'm like, so for the ones we just did, it says IDE instead of ITE.
If it was I'd, then it would be some metal and oxygen. If it's NGO, then it's magnesium oxide. This is ITE and ATE. When it's just oxygen by itself, this is one of the polyatomic ions. So you might get, what is the one? That's a good question. I guess I should just make some up. Lost. Oh, sulfate, okay, well. Notice that that's one negative, so let me do NaClO minus. Or I could do beryllium is 2 plus, so that would be ClO2. Because this is only one negative. So So I would need two of them. So this would be called, this would be called that would be called sodium chloride. Na2O would be oxide.
So when the oxygen is by itself, then it's ion.
That's when it's I.
Okay.
When it's paired with one of the halogens, then you follow this scheme. If it's one oxygen on a halogen, it's hypo, whatever the halogen is, ite.
Okay.
Did that help?
That's the answer to my question.
That was your
Thank
question.
you.
Good. So there is that pattern to pay attention to. What else do we have in here? Cyanide. You want to do more of these? All right, lead, tin, and carbonate. So you've got the carbonate, polyatomic ion, and lead, tin. So it says lead 2, and that would be Pb 2 plus, and carbonate. When you would look back page of the test or wherever I put it, you can look for carbonate on here. It's up here, CO3 2 negative. Carbonate is CO3. So that's 2 negative and that's 2 positive, so it would just be Pb. And the name of it is I had to put the 2 here. Some fonts have the capitals on top and bottom, and some fonts just do it like that. Usually when I write a test, I try to find the font that does that. Just to me, that from your name. That's lead 2 carbonate.
Will there be any questions for the before first, and then we'll have to?
Yeah, you might be given this and asked, what is the charge on lead? So then you would have to think of it as CO3 has what charge on it? And then you would look in this chart and find that it's 2 negative. And then you look up here and go, oh, there's only one lead there, so it's got the lead has to be 2 positive. What about something cool here? Cobalt is charged 2. So how about that one? What is the charge on iron? And sort of the way to chart that out is you're going to infer the charge on iron because the charge on oxygen is known. There's 3 oxygens, and oxygen is 2 minus, so that's a total of -6. So we need a +6, and there's 2 irons. So we got to split that +6 up into 2 irons, so it'll be 3 plus, 3 plus. So the charge on iron is 3 plus. Therefore, the name of this is iron 3 oxide. You guys want to do more? We've still got Friday. So I'll see you guys Friday. And be looking over those questions and deciding, look over the quizzes and questions in the back of the chapter. and decide what you want to ask about. Keep Ellie in mind.